Chapter 10, Think and Explain. Number 40. Suppose you roll a ball off a tabletop. Will the time to hit the floor depend upon the speed of the ball? Now, we're saying rolling off a tabletop. We assume that the table is level, and so that when it comes off, it's going off horizontally. So, no, it doesn't. Because it's going to move to the ground because of the force to the ground. Its initial velocity vertically, which is a vertical thing, the initial velocity vertically is 0. And so it's just like you're dropping an object. So the speed doesn't matter. And then parenthetically, how will a fast ball take longer to hit will a fast ball take longer to hit the floor? In the absence of air resistance, no. Assuming that, I think, is the spirit of what he's asking here. Do realize that if you do, I don't know if it's physically possible, but if it is, I mean, it could take longer if you give it some orbital speed. Of course, it'll probably hit the wall or something. So it will take longer if it's traveling so fast that it starts falling at the rate at which the Earth is curving away from it. In other words, orbiting. 41. Suppose you roll a ball off the tabletop. Compared with a slow roll, will a faster moving ball hit the floor with a higher speed? Yes, it will. Energy is conserved once it leaves, and so if it starts out with more energy, it will end with more energy. Even though the vertical component of the velocity will be the same, the horizontal component is different in those particular cases. And so, again, the final speed is the combination of the horizontal velocity added to, it's the magnitude of the sum of the horizontal velocity and the vertical velocity. Vertical velocity is the same for each of them, but the horizontal velocity would be different. So faster off the tabletop, faster it hits the ground. The fast, not time-wise, that isn't, it's going faster. 43. Heavy crate accidentally falls from a high-flying airplane just as it flies directly over a tiny red Porsche. Or Porsche. Smartly parked in the car lot. I'm not sure how you smartly park something, but relative to the Porsche, where will the crate land? It'll land in the direction that the plane was moving at that moment, because the crate has an initial horizontal velocity, so its projectile, it will just keep going. The plane people would have to plan ahead of time. Thus, that's why there are bombardiers in planes. Got somebody predict when you have to let go. 52. When you jump upward, your hang time is the time your feet are off the ground. Does the hang time depend on your vertical component of velocity when you jump, your horizontal component velocity, or both? It depends upon the vertical. Because the vertical is the part, the force is vertical, the acceleration is vertical. More specifically, acceleration is down once you leave the ground. And so that is going to affect how long you're in the air. It's your initial vertical velocity. Because if you start at, say, 100 meters per second, it's going to take you 10 seconds to stop. If you start at 10 meters per second, it'll take you about a second to stop. So, yeah, and horizontal component is not affected. That doesn't change. Yeah. Answer defended. 57. Oh, here comes Bohr again. How does the speed of a falling object depend on its mass? And does the speed of a satellite in orbit depend on its mass? And no, it doesn't. Because ultimately, if you look at the math, big G m1 m2 over r squared equals ma. The mass of the object drops out, it cancels out, and so it does not. That's my defense. 67. What is the shape of the orbit when the velocity of the satellite is everywhere perpendicular to the force of gravity? Force of gravity is always towards the central object, or the one at the foci if you're talking about elliptical orbit. But if it's always perpendicular, that's a circular orbit. That is classic. If the force is perpendicular to the velocity, that means the acceleration is perpendicular to the velocity. That is centripetal acceleration, therefore centripetal force to the core. And 82. At what point in an elliptical orbit about the sun is the acceleration of the Earth towards the sun at a maximum? It's at a maximum when the force is the greatest, F equals ma. Mass of the Earth isn't changing appreciably. And so if we're going with, actually I'm not sure if the diagram goes with this, with 81 or 82, but the acceleration is the greatest when the Earth is closest, and minimum when it's farthest away. Now, there are various points, not asking about where's the centripetal acceleration the greatest or where the tangential acceleration is the greatest. So, actually, those would be the same answers, I believe. No, tangential acceleration is not the at a max and min there. Yeah, there it is. Yep, and the dog's licking my hand, so hard